Hello everyone. This is a video for our next lesson, which is intersections of lines in 3-space. But of course, we're going to go back first to 2-space to start with some familiar territory here. So when we're doing 2D, again, this goes back to tiny bit in grade 9 and then mostly in grade 10. There's 3 different ways that 2 lines can intersect with each other. Okay. So the most common option, right, is that they go in different directions, okay, and they meet in a single point. Okay. The second option is that the 2 lines are parallel, okay, and that they never meet. Okay. And the third option, and this is the sneaky option, is if the 2 equations you got were actually the same line twice, and they sit right on top of each other. Okay, and even me trying to draw it wasn't quite perfect there, but right, those are your 3 cases. Okay, algebraically, this is one solution. Okay, this is no solutions. Okay, and this is infinite solutions. Okay, now you would have solved for this by doing like substitution, elimination, something like that. Okay, and just talk about what the solution would look like. Okay, in the one solution case, you would end up with a point. Right? You get some point x, y, you'd be good. Okay, if it has no solutions, okay, it would have meant that somewhere in your steps, you would have got to something equation that looks like 0x equals, I don't know, 7, which means 0 equals 7, and that's impossible. Okay, so there's no solutions. Okay. If it has infinite solutions, if you're trying to solve your equations by substitution elimination, you would eventually get to something that looks like 0x equals 0, or 0 equals 0, and this is always true. And that's why it has infinite solutions, right? So either you end up coming down to a point, you get something that makes no sense, which means you have no solution, or you get something that's always true, which means everything is a solution. Okay. Now, we're going to talk about how to do this with equations, with vector forms of the equations. So we'll get right into it. Determine the point of intersection between these 2 lines. Okay, so in this process, we'll end up using the same tools that you used in the grade 10 course. We're just going to start by writing these out in the parametric form of the equation. Okay, so for my first equation, line 1, okay, my parameters are, I have x equals 1 plus t, and y equals 1, not 1, 3 plus 2t. Okay, for line 2, okay, we have x is equal to 0 minus s, so minus s. Okay, and y is equal to negative 2 plus 3s. Okay, I'm looking for the point where these 2 things intersect. Okay, well, wherever that would be, that means the xy coordinates would be the same on both lines, right? If this works, I should get the same thing for x here and here, and the same thing for y there and there. So that just means that these 2 should be equal, so I can set those first 2 coordinates equal to each other. I have 1 plus t equals negative s. Okay, and the y parameters would also be equal to each other. So 3 plus 2t is equal to negative 2 plus 3s. Okay, and now I have a system of 2 equations and 2 unknowns. Okay, just like you would have had trying to solve these way back in grade 10. Okay, it's just got different letters. Okay? It's not x and y, it's t and s, but same principle. I now have to do substitution or elimination, right? Something to work these out. Okay. So I'm going to choose substitution here because my first equation, one side is just negative s, and it's really easy to solve for s. Okay, if I multiply the whole thing by -1, I'd have -1 minus t is equal to s. And now I can substitute that into the second equation. Okay, so that's going to go in for s. So now I have 3 plus 2t equals -2 plus 3, -1 minus t, and I'll solve. So 3 plus 2t equals -2 minus 3 minus t. So if I bring the t over, I have 3t. If I bring this 3 over, I would have -8. And hold on a sec. I realize I made a silly algebra mistake. That happens sometimes. Okay, that should be -3t because I'm supposed to distribute those in. Okay, resume. So that should really be a 5. Okay, so t is equal to -8 over 5. Okay. Now I have t, I can figure out s. So I'll go back to this equation up here. So s is equal to -1 minus t. S equals -1 minus -8 fifths. Okay, so that's -5 fifths plus 8 fifths, so 3 fifths. Okay, so the solution to my system is that t equals -8 over 5 and s equals 3 over 5. Okay, but I'm not done because that's not the point of intersection. Okay, the point of intersection is what I get for x and y. So now I pick one of my original equations. I think I'll grab the first one here. I have to substitute in the appropriate variable. Okay, so this one was in terms of t. Now I plug in my values for t and see what I should get. So for the x coordinate, I have 1 plus -5. So that should be equal to, that's -3 fifths. Okay, and in the other equation, I have 3 plus 2 times -8 over 5. And that would be equal to, that's 15 fifths minus 16 fifths, so -1 fifth. Okay, so the point of intersection is at -3 over 5 and -1 over 5. Okay. Okay, and this is a quick check here. It said s was 3 fifths. So if I go to my other set of parameters, right, I definitely get -3 out of 5 for x, so I'm probably good here. Okay, but there you go. There's the point of intersection. So it's a lot like it was back in grade 10, just with a little bit of an extra step there. Okay. Now, one thing I forgot to mention at the start here is I ended up getting the point. Okay, and I knew that in advance because if I look at the direction vectors, okay, they're definitely not parallel, right? Those are not scalar multiples of each other. The lines have 2 different directions. They had to meet in the point in 2D. Okay, and I'm bringing this up for the purpose of example 2, right? Determine the point of intersection of these 2 lines. Okay, so to make sure I know what I'm looking for, okay, I quickly check those direction vectors, okay, and they are scalar multiples of each other, right? If I multiply the first one, -4, 3 by -1, you get 4, 3 for the other one. So these lines are actually parallel, okay? Now, I don't know if they're 2 different lines or if it's the same line twice. Okay, so I still have to figure that out. So there's a couple ways we can do this, but I'm still going to write out the parameters to start. Okay. So line 1, x equals -1 minus 4t, y equals 7 plus 3t. Okay, line 2, I have 3 x equals 3 plus 4s, and y equals 3 minus 3s. Okay, so there's two ways I could solve this. Okay, one would be to follow the exact same steps as I did before. Okay, so let's try that out and see what happens. Okay, so my first pair, I have -1 minus 4t would be equal to 3 plus 4s, right? That's comparing my x parameters. Okay, and my other equation is 7 plus 3t equals 3 minus 3s. And now I'm going to try to solve this for s and t. So just to practice, let's try elimination this time. Okay, maybe that's not going to be super nice, but I'm going to rearrange first, so that might help me here. Okay, my top row, when I bring the 4s over, I'm going to have -4t minus 4s is equal to 4. Ooh, that's nice. So that simplifies to -t minus s equals 1. Okay, my second equation, I'm going to have 3t plus 3s equals -4. Okay, and again, that reduces nicely. I have t plus s equals -4 over 3. Okay, so for elimination, I'm going to add these two equations together. So -t plus t is 0, -s plus s is 0, and 1 plus -4 over 3 is -1/3. That says 0 equals -1/3, but that's nonsense. Okay, so this has no solution. Okay, I tried to solve it and it didn't work. Okay, the other way that we could approach this is if I didn't want to do this, if these are the same line, okay, and I'm just trying to be tricky here, okay, well, that would mean that the different points, right, this point should be on line 2, and this point should be on line 1. Okay, so I'm going to use line 2 to test this out. This would be like alternate method. Let's write this in here. So method 2, check if point from other line is on. Check if point from one line is on. Okay, so this is line 2, line 1, line -1 and 7. This is something we did earlier on. Okay, so I would have 1 equals 3 plus 4s. And it was -7. No, -1. Okay, and 7 should equal 3 minus 3s. Okay, and now I solve each equation for s and see what I get. So for the first one, the 4 would come over, and I divide it out, so I'd have -1 equals s. For the second one, the 3 comes over, so that's 4 divided by -3, and I get -4 over 3 equals s. Okay, these S values are not the same, so therefore point -17 not on L2. Okay, therefore no solution. Okay, these are not the same line. Okay, so now that we've gone through that, we're ready to make the jump to 3 dimensions. Okay, in 3 space, the cases are really kind of the same. Okay, they could, however they're traveling in space, we could have one solution. Okay, we could have that they are parallel, okay, and we could have that they're the same line twice. Okay, but there's a new situation, and again, it's going to be a little bit hard to draw here. But if I have a line up here, okay, and if I have a line going a different direction, but it passes underneath the other one, and there's actually a little bit of distance between these 2 lines, okay, right? So, like say if you were driving on the freeway, right, and there's an overpass, right, where the bridge goes over top, like a flyover type thing. Okay, that's kind of what we're talking about here, right? They're lines in space, but they don't actually meet because one is above the other. Okay, if you've ever seen, 2 airplanes, their paths crossing in the sky, right? One goes up, one goes underneath. They don't touch each other. Okay, so that's the only other thing that can happen. But the other 3 cases can happen as well. Okay, the name for this situation is called skew line. Okay, if they are non-parallel, but they don't meet. Okay, so for our last one, we're just going to find the intersection of these 2 lines. Okay, and the setup is going to start exactly the same way. I'm going to write out my parametric forms. So x equals 1 plus 2t, y equals, I have a 0 there, so it just equals t, and I have z equals 1 plus 3t. Okay, for line 2, okay, we have x equals -4 plus s, y equals 3 minus 2s, z equals 1 plus 5s. Okay, now this is a little bit weird because I've got 3 equations and not 2, but we'll set it out the same way. So maybe I'll equate my first 2. Okay, so my x parameters would give me that 1 plus 2t is equal to -4 plus s. And I definitely want to use my y parameter because that's just t is equal to 3 minus 2s. Okay, and I'm going to solve these equations for t and s and see what happens. Okay, so this is nice because I can just substitute, right, 3 minus 2s in for t in the other equation. So I have 1 plus 2, 3 minus 2s equals -4 plus s. 1 plus 6 minus, oh, let's do it again. That is -4s equals -4 plus s. Okay, so on this side, I'm going to get 5s. On that side, I'm going to get 11. So 11 over 5 equals s. Okay, and then I need to plug that back in. So t T equals 3 minus 2 like this. So T, let's see, that would be 15 over 5 minus 22 over 5. So minus okay, so there's my value of S and T. So the last thing I need to do here is verify that third equation, right? Because I had a third pair of parameters, z equals 1 plus 3t and z equals 1 plus 5s. So I need to check and see if this actually works in that last pair of parameters. So bear with me here while I copy them down again. So z was equal to 1 plus 3t, and I think z was equal to 1 plus 5s. Yep, okay. So over here, I've got 1 plus 3 times negative 7 over 5, which is the value for t. And that's going to be negative 16 over 5. Okay, s is 11 over 5. So 1 plus 5 times 11 over 5. And that's like 60 over 5. Oh, yeah, that's 12. Okay, so I plugged in S and T into the respective parameters for Z, and I did not get the same thing. Okay, so since V values agree, okay, there is no solution. Okay, and now just to check, back at the top, okay, my direction vectors were different. Okay, they're definitely not scalar multiples of each other. So that means that these were skew lines. Okay, these were skew lines. Okay, so that's basically the entire lesson, right? So to find the intersection of lines when they're in vector form, you write out the parametric form, okay, you set the parameters equal to each other, okay, solve two of them, so solve a system to figure out the values of S and T. And then in the 3D case, you have to check and make sure that the third parameter works out. Okay. So there's the recommended practice starting on page 472, number 2 to 6 AC, 8 and 11. Okay, and of course, like last time, if you have questions about it, feel free to email me and I will address them before the next lesson. Thanks, and I'll see you in the next one.